Okay.
Okay. So, we are starting mod 7, and of all these kinds of motion, this is the one we're going to be in the whole mod. But, should we rename it Rotational Dynamic Equilibrium?
That's no.
Okay.
Sounds too sciencey.
So you can see on your papers, we're going to call it Uniform
That's only 12 syllables.
Circular. How much is
It's not that
this?
bad.
How much is Uniform Circular Motion? That's what we're going to call it. It is identical to this idea of rotational dynamic equilibrium. But we're going to call it uniform circular motion. So, lots of times I teach all day, well all day, 1 50-minute slot, and I come back the next day, especially on day 2, and nobody remembers what we're studying.
Can we just do
I
RDE?
thought that we could all just do some uniform circular. Uniform means it's going around at the same speed. Obviously, I'm giving it a little twist at some point, so it's not exactly, but as much as I can, I am doing uniform circular motion. So everyone can create some uniform circular motion. Stand up, get it far away from the other guy. And you can use either side.
Like nunchucks.
This is like
No pal.
What's something I live my life?
Alright, well, you're right next to you.
Alright, start creating uniform circular. You can change the length of that with your
Oh, no,
finger.
oh, you make it a kunai.
Alright.
I'm gonna go in the middle.
Alright. Pretty uniform.
Ow.
I don't know where to stand under the table is about right.
I'll hold one
Okay.
arm. You got it.
Stop.
Yeah, now you just need your cowboy hat.
Alright. Watch the camera. Watch the camera. Alright.
I'm gonna make my very
Looking
small.
pretty uniform. Alright. Will that help you
What just
remember
happened? I
tomorrow
don't
what
even
we're
know.
studying?
Keen lost
It
her
was like yours or
washer.
mine. I thought it was mine. Because it like
She lose her dryer
too.
Okay, go ahead and take those back to your table. We might use them later today. So, take them back.
I don't know how to do it. I've never seen the one for
What you were
Chinese
creating there is what we'll be studying for the
Levitate.
uniform circular motion. Alright. I was wondering, this is where you're going to start taking notes. So, I would like you to not reading the phone, but I don't get that. Alright. We'll just wait for someone to give up. They gave up. Okay. Alright, I was wondering, let's go ahead and look at some motion. So go ahead and draw an example on your paper. How good is your circle?
I cannot draw.
Alright.
Brian.
That was not the best, so you could probably do better than this.
Yep.
So draw a circle indicating an object in circular motion. So draw yourself an object that's going around.
I haven't seen this since Sunday.
Let me see your circle.
My circle with a
And put an object on the circle so you can know.
I don't know. I'm extra ruthless today. I'm like packing on people. It's been Victoria's.
Under or around that circle, I want you to write this question and think about the answer. I'm sure you've been wondering, is the acceleration of this object
Here's the question listed. And then she came around.
write down this question next to the circle
Oh,
that you
mother,
drew.
come on.
Have you been wondering, Alex, if the acceleration is 0?
Yes.
All right, write
Last
that
night.
down.
In my bedroom.
And rolling around in your head.
Yep. Late night thoughts.
It's like
No.
very ugly.
Is the acceleration of this going around at a constant speed, because I told you it was, and I had you demonstrate one that was nearly going around in constant speed. So, we recall from our past, like probably mod 1, in our thoughts always, is acceleration is the change in what over change in what? Do you recall, Emily? That's calculus.
Calculus, you little calculus student, you.
Change.
Isn't it changing some wires in time?
Change
Time,
in
I'll take
velocity.
time.
Time over.
Velocity.
Velocity.
Yeah.
Velocity over
Trying to take a derivative of it.
The derivative of velocity is acceleration, but that's so we could say dv dt. We could. So she was aiming in the right direction.
It's not aim there.
So,
Okay.
acceleration is the change in time of velocity over the change in time. So, is the acceleration 0 here? So thinking of it in terms of that, where is velocity when you're going in a circle? It's kind of interesting in that the velocity vector, if I was going to put it at this spot, you have to envision, what if this was going around and I suddenly, for an instant in time, cut the string? Where would the object go?
It would probably go in a straight
fly
line,
out.
Right, it
tangential to the
is. So
circle.
if you would draw
Yes.
in that.
Oh, it's like tangent. It's like
Very good, I was going to say that. How did you
Let's
know?
Woo!
All right.
Geometry, I remember this.
All right, so I was going to say, what is the geometric
it's like a
term
tangent
for
or
a
something.
line that touches a circle in one
You're
point?
petty.
But
You're
So you
petty.
go on the derivative.
You're a petty
So-
dude.
Yeah, it's just the whole thing they've been doing.
Let's see.
the velocity,
Here.
so draw in a tangent line at the point where your object is, because that is the velocity vector for this object in circular motion. So I'm going to draw, let's say the point went over here, draw the velocity vector in several points on your circle. So this, in mine, it would go like this. So at each point, I'm imagining the velocity of the object. Should I cut its by
Why do we put so many dots on it?
Take the scissors and cut
Because
it
it
right
moves
at
around
that
in a
point.
circle. Well, why don't
What's
we-
that?
why
What was
don't
your
we dot?
question?
We just put a lot of dots on it. Why do we do
Yeah,
that?
we are looking at what the velocity would look like at different spots on its
Oh,
journey.
okay, okay. Alright.
Circles. Yeah, mine is too. Start out.
So let's go back and now see if this helps us answer, is the acceleration 0? Before your conjecture, recall acceleration was a vector. I believe it was written emboldened in your textbook. Sometimes you see it with a little hat like that. It's a vector quantity. So vector quantities have magnitude. And does it look like the magnitude would be the same all the way around? Is the length of your vectors going to be identical all the way around? Should be, because I said uniform, so you're trying to create the same speed all